Welcome to Talkcast and to part one of the penultimate chapter of The Fabric of Reality by David Deutsch, titled The Four Strands. This is a chapter in two distinct parts, in my reading of it anyway. First, we get to some theory. It is the theory of the tension between philosopher Karl Popper and his worldview when it comes to how knowledge is created, and Thomas Kuhn, historian and sociologist of science, and his view about how science moves through revolutions and periods of normal science rather than actually discovering objective knowledge. The second part of the chapter is about applying these two different visions of how science works to the four strands: Everettian quantum theory, evolution by natural selection and the selfish gene, computation and epistemology. So the second part will deal with some of these philosophical and sociological issues with respect to the four strands, and also reveal some open questions and more about the connections between those four strands. Now, in this chapter, precisely because it does mention Thomas Kuhn, it runs the real risk of me talking your ear off about that particular thinker. More than normal anyway. I know I talk your ear off most of the time when I do these episodes. I could spend many hours discussing Kuhn. Thomas Kuhn wrote the most cited book in the humanities, the most referred to book, titled The Structure of Scientific Revolutions, and it still holds that record. And it amounts to, basically, a challenge to Karl Popper's philosophy of science. Taken literally, Thomas Kuhn seems to throw into the same basket the way in which scientific theories come and go as the way in which skirt lengths rise and fall. In other words, it's just a matter of fashion rather than objective contact with reality. There's no objective reason why fashions might change. It sort of all comes down to the whims of people in the fashion world, purely subjective impulses, emotions and feelings that they have. So Kuhn is making the case for science being driven, largely, by irrational forces, social forces and psychological and emotional impulses. That's what drives science, according to Kuhn. Not merely scientists, but science itself. Or rather, because scientists are human, because they create hierarchies, that means that what you get in science is the result of power struggles. It's all very Marxist. Or is it? Now, if you spend any time listening to someone like Jordan Peterson, who has some excellent analysis of Marx and his descendants do not like class or hierarchy. They think that where such structures exist in society, like between the CEO in a company and the newest recruit, that should all be flattened. If there exists a wealth disparity, flattened. It's a sign of perversion in society as soon as you have differences between people, differences in outcome, differences in opportunity. Everyone should earn the same. So I've critiqued this before. What Peterson and so many others observe is that human beings just have hierarchies, not in terms of pure brute strength like other animals, or they do have that in some places, like maybe in a gang or in weightlifting. But we human beings in complex social systems develop hierarchies of competence, which means one can ascend a ladder of salary or a ladder of responsibility, given one's demonstrable effort and ability. Or knowledge, in other words. Not unfailingly, it's a fallible system, but it's better than those others that have been tried from time to time, like brute force, brute strength. Hierarchies of competence are not all bad, or even partially bad necessarily. Whatever the case, hierarchies in human societies exist. And we've known this for a long time. They've been around since time immemorial. But this fact, rather simple fact really, is elevated to a philosophy by Thomas Kuhn. And Kuhn is someone you will read if you do a degree in something like, let's say, the philosophy of science. And you'll read about all the people associated with Kuhn as well. And this is a strangely perverse phenomenon I've observed. I was coerced, required to read Kuhn as an undergraduate, so very, very early on in my university studies. And I thought the point he was making was rather trivial. I in fact read Kuhn before I read any of Popper and before I read The Fabric of Reality. So before Deutsch and before Popper, I read Kuhn, and intuitively, upon reading Kuhn, The Structure of Scientific Revolutions, I thought, no. I just thought no, because I was doing physics at the time. And I thought to myself, But physics is clearly about reality. People are doing experiments. They're testing their ideas against nature. It's not fashion, it's not hierarchies, it's not power struggles or anything like that. People aren't just trying on for size these different theories like they would try on a new outfit. It was deeper than that, and I didn't understand what point Kuhn was making. And by the way, the people that were teaching me this stuff about Kuhn, they were from the Faculty of Arts more often than not. They weren't scientists. The way in which I was taught in my science lectures, when we did do a little bit of history of science, and quite often you do, it wasn't about social forces in the main. It was about whether or not a particular explanation solved a problem. Now, I wouldn't have put it in those terms at the time, but I understood it was about reality, not just someone's opinion. Even though I wasn't using those words objective and subjective at the time, I understood the concept. This was back in the late 90s, and I was reading a lot of guff back in the late 90s as well. I was required to, and I wasn't impressed by it. Later, I read a philosopher called Imre Lakatos, and I found him difficult to understand. Kuhn was rather easy to understand, Lakatos rather harder to understand. In retrospect, I understood why when I went back to reread Lakatos. And that's because Lakatos blends Popper and Kuhn to try and get the best out of both worlds, but I think he just ends up sitting on the fence and mangles both of their ideas. To me, it just doesn't work. It's poisoning the well of Popper with the nonsense of Kuhn. But I should say, Kuhn isn't entirely talking nonsense. Sometimes he's talking nonsense, but often he's talking trivialities and revealing problems that are easily solved. The thing about Lakatos, who tries to blend the two, on the one hand, is science and what is produced by science a consequence of social forces and the way in which frameworks operate, or paradigms as he talks about, or is it to do with people conjecturing bold ideas and testing them against reality? That's Popper's view. Is it a combination of the two? Well, I didn't think it could be a combination of the two, because science produces objective knowledge, or it doesn't. And the way in which we know is via the process of science. If it does, then what is the process that accounts for this capacity to generate objective knowledge about physical reality? Popper ends up explaining all of this. Now, if it doesn't, when science goes wrong because the scientific community has perhaps made an error, okay, maybe then we can talk sociology at times, or we could talk errors in the equipment and the theory. But really, the sociological stuff is a kind of a side issue for science. It's not a side issue for the scientific community. It's not a side issue for, let's say, who gets the funding and so on and so forth to do science. But as for science, that's different. The scientific community is not science. What scientists are up to is often science inside the lab, but they're also up to other stuff as well. But so are people engaged in every single human activity. It's not a unique issue for science. The same can be said for business, the world of literature, for sport, for art. Sometimes there are special interests and cliques and all that kind of stuff. And there can be fashions that come and go as well. But that's not what you get out of the end of doing science. Science is an error correction mechanism. But scientists and their funding bodies can form hierarchies. And sometimes good ideas can be suppressed, and sometimes bad ideas promoted. But the whole point is that if the machine of science, that error correction machine, is working well, and quite often it is, it's blind to all of that stuff, literally blind. And so if you come along with your bad idea and do get funding, well, science doesn't care about how much funding you've got. Science will test your theory, evaluate your theory, criticize your theory, and ultimately, if it's a bad one, refute your theory for everyone to see. For example, that's what happened with the cold fusion debacle that I've talked about in live streams and here on Topcast as well. It got lots of publicity, lots of funding. It seemed unfair to the people who were doing good work when it came to, let's say, cold fusion or fusion more broadly. But those researchers, Pons and Fleischmann, they were refuted. And ultimately, the scientists punished reputationally. I see this kind of thing still happens. There are many names to talk about when it comes to this intersection between what might be called the philosophy of science. When some people talk about the philosophy of science, they're not doing what I would regard as the philosophy of science. But if you think about what goes under the umbrella of the philosophy of science in most institutions, like the university, they will often throw in Kuhn, which is really sociology, about how the community of science tend to behave human behaviour, in other words. There's a lot of psychology there, sociology. And so you get people like Thomas Kuhn, you get people like Imre Lakatos, and you get people like Paul Feyerabend as well, and all of their hangers-on and intellectual descendants. And it goes from somewhat sensible remarks, which, as I say, are fairly trivial about the way in which humans tend to behave and tend to get excited about new ideas and perhaps suppress some of them some of the time and elevate some of them when they don't deserve to be elevated. And all this sort of stuff happens, as it does in business when some new widget is produced and everyone in the market thinks that it's going to do well and it doesn't do well. This sort of stuff can happen. Things can take off for no good reason. But all of that is fairly sensible in terms of analysis of what happens with humans. But with the science stuff, with philosophy of science, people quickly slide from there to conclusions like, well, therefore science can't possibly reveal any knowledge, any objective knowledge about physical reality. And moreover, maybe there isn't an actual reality out there. In other words, realism is false. People reach all sorts of strange conclusions once they hop on the bandwagon of Kuhn. Kuhn isn't responsible for all relativism, but he's responsible for a path that leads to relativism for some, and some not insubstantial number of people who are, let's say, academics or intellectuals in the humanities and social sciences. I was made to read all of these people, and it was torturous. Popper, as I've said often, as far as the actual university went, was regarded as kind of a footnote, a side issue. The guy that did falsification, okay, the guy that thought that science was about conducting an experiment just to disprove hypotheses. And everyone says, well, it's not as simple as that. And of course, Popper knew it wasn't as simple as that. And everyone thinks the Duhem-Quine thesis, for example, which says you've got to look at whether or not your equipment might have malfunctioned. That all of this is stuff that Popper was well aware of. And Popper was well aware of the sociological aspects of the scientific community as well. So I didn't know that. And I didn't much know about this guy Popper until I read The Fabric of Reality in 1997 by David Deutsch. And he mentions Popper, and so later on I read Popper. And then I thought, well, no wonder I was uncomfortable as a physics student doing a little bit of philosophy, reading Kuhn, Lakatos, Feyerabend, and various other people, and feeling uncomfortable. It didn't ring true. Not until I read Popper did I realise, there is someone who talks about the philosophy of science and knowledge, epistemology, who seems to get it right. I wasn't throwing all philosophy out. I thought Descartes was quite good. I thought David Hume was quite good. I even thought Spinoza, who was very difficult to read, was quite good. But there were some people who were just impenetrable, and where they weren't impenetrable, they were trivial. Popper's not like that. He is both clear and deep, in the same way that I was often told that Wittgenstein was this great genius, and yet I found him difficult to understand, and insofar as he was making the claim that all of our thinking is couched in terms of language and we can't think about things that we can't express in language, I thought, again, that seemed trivial but also false. You can see my podcasts on Wittgenstein for more about that. But the interesting thing is that although I was made to read these thinkers, Kuhn, Lakatos and Feyerabend, and thought they weren't really making much sense, they weren't very impressive. Later on, when I read myself, Deutsch and Popper, and I was impressed, and I thought, this is the real stuff. Why weren't we being made to read this at university? It's still a mystery to me. The new phenomena that I'm encountering is that now that I have this podcast, and it's a place where people come to listen to me talk about Deutsch and Popper, among other things, sometimes I have fans of the podcast who'll be fans for hundreds of episodes of the podcast. They'll take a deep dive on Popper and Deutsch, and then they decide they're going to read Kuhn or Lakatos or Feyerabend, or they do, and then they become starry-eyed about them. And they tell me, Brett Hall, you should read Kuhn and Lakatos and Feyerabend to broaden my mind because I'm in an echo chamber of Popper and Deutsch. And Popper and Deutsch, it turns out, they say, never really understood science and epistemology after all. Lakatos did. He really got it. So it's quite the thing that I encounter. What I might do is actually have a special episode, not this one, and not part of the Fabric of Reality series, all about that kind of stuff, because those three names in particular, and David doesn't mention Lakatos and Feyerabend apart from as a reference, but those two and Kuhn, I really should talk about more because they're merely the tip of an iceberg when it comes to some people's conception of what science is all about. As I say, most of what mess came after them, the mess that started with Kuhn, he could not have predicted what would have followed him, rather like Wittgenstein. It's still with us today. People who deny, for example, especially in academia, the objectivity of science, people who want to reduce everything to language or social games. As I say, Popper dealt with all of this. He understood the significance of hierarchies and what can go wrong. But as I've said, Popper, understood the difference between science, the objective process of correcting errors in our existing knowledge and making progress, versus the scientific community or scientists themselves. It's a huge topic, and I do mean huge because entire semester-long courses are taught on this stuff, whole degree programs almost, and most of those tend to fall into the pit, ultimately, of utter relativism. The colloquialism, from the sublime to the ridiculous, never has more currency than when one attends a seminar or lecture on the sociology of science. One usually begins with some gentle-sounding ideas from Kuhn, and before you know it, reality itself doesn't even exist. Now, Kuhn never said that. We can't blame him, but it's amazing how his own field, sociology really, is now all about power and hierarchy. And that is something David writes about in The Beginning of Infinity, chapter 12, A Physicist's History of Bad Philosophy. As I say, I'm somewhat inspired to do an episode comparing and contrasting Popper versus Kuhn and Lakatos and Feyerabend and their many students, associates and intellectual descendants. Descendant is the right word there because it descends quite rapidly into complete irrationality. The field, which is often called either sociology of science or science studies, that is a pit of despair when it comes to trying to figure out what is actually going on in science. It has nothing to do with science, despite the fact it's called science studies. I mistakenly took a couple of science and technology studies courses at university in Sydney once, and a course in the history and philosophy of science because, hey, that sounds good, doesn't it? But it was packaged relativism. So I've been there, in the belly of the beast. Many have said before, if you put the word studies into the title of a subject area, you know what they're doing is not studying that particular thing. I can tell you firsthand, they're not doing philosophy in the history and philosophy of science, for example. And they're not studying science in science studies. They're utterly disconnected from science and generally completely ignorant of it. It's amazing. You don't generally get science students taking those courses, by the way, because they're usually not offered it, at least at my university, in the science faculty. I had to go looking for this particular stuff in the handbook. Those subjects were offered by the arts faculty, and not even by the School of Philosophy. They had their own department. I don't know if it still exists now. I'm sure it would have been wound down. It was this tiny little pokey department of like 5 professors and a few graduate students and that kind of thing. But they taught courses to the undergraduates. And it was literally called the School of Science and Technology Studies at the University of New South Wales. The professors, all arts graduates. And the students were all arts graduates. And the whole point was to ostensibly analyse what they were doing over there in the science faculty. But it was all nonsense. It was all just how science was about power and about how the history of science was, well, looking back about the patriarchy, and you get the picture. It was all nonsense. I expected to learn literally about the history of science. And I guess about 20% of the time you did. You got, well, here's Copernicus and the Church and Galileo and Kepler and Newton. But also you would get, well, that's just one way of thinking about how reality works, is to do this thing called science. The subtext all being, what you're doing when you're studying the history of science is studying the inner workings of the psychology of white European men. Now, today, that's not merely a subtext in many of these courses. It's the headline and neon lights. Now, it's also worth noting at the moment, by semi-happy coincidence and a little planning, it's meant that this chapter that I'm reading here now from The Fabric of Reality, the 4 strands, I'm reading in concert with a series I've begun on The Myth of the Framework by Karl Popper. You'll notice that this particular chapter in The Fabric of Reality, I'm bookending on Topcast with The Myth of the Framework, because both are speaking about very similar things. So we can hear from both Karl Popper and David Deutsch about our ability to understand other perspectives, other frameworks, paradigms or theories, basically without bound, which is quite unlike what the people they are refuting claim. Now, I don't really want to turn this into a personal reflection on my time at university, although I tend to do that quite a bit in Topcast. It's revealing what goes on if you haven't been to university what happens behind the scenes in some of these places. Because my experience may not be representative, I don't know. I spent most of my time studying physics, but I also did philosophy of science, as I've talked about before. And in my philosophy studies, I was expected to read Kuhn extensively and all of his offshoots. But as I already said, Popper was like a footnote, truly. And in my experience and having done Topcast for, I guess, it's coming up to a decade now, lots and lots of people have indeed read Kuhn and contacted me over the years asking me if I have. Because they've read it just out of interest, or their professors made them read Kuhn and did not make them read Popper, but often did tell them about Popper and how Popper was wrong because, well, Kuhn explained how. And so I continue to hear from people about all of that now, about how Kuhn is right and Popper is wrong. They even tell me, you should read Kuhn, Brett Hall. And as I've already hinted at, there are others who followed me for a while on Topcast and like Popper and Deutsch, and then they have this strange awakening. I think it's a darkening. And one day they just kind of snap and they tell me they've read Kuhn or Lakatosh and now realise that Popper was wrong and that I should read Kuhn and Lakatosh, which again goes to my theory about the last thing that some people read seems to be what they're convinced by. But what I think is, of course, when it comes to that kind of reaction, they never really understood Popper or conjectural knowledge, because if they did, they wouldn't be so dogmatically wedded to this new idea they've got about Kuhn and how right he was. Now, it's worth acknowledging. Thomas Kuhn was a physicist, but as I've observed many times before on Topcast, that does not inoculate one against relativism. Today, a number of physicists in the public sphere are relativists, both on morality and on science. They won't, for example, say that science actually tells us about reality. They'll say, science is just a tool for making predictions sometimes. Or reality doesn't matter, it's just in your head, something like that. I've spoken to these people. But for what it's worth, and to not get ahead of myself, I was never hugely impressed by Kuhn, as I say. There's not much there. It's just this idea that scientists are people and sometimes people are irrational. There's this thing called a paradigm which blinds its adherents to other paradigms or ways of thinking. As a critique of the behaviour of some scientists sometimes, okay, it's good, but as a description of the process of science itself, it falls apart and is superficial. This idea of paradigms never seemed to be that deep. Of course I can understand other paradigms. What's he talking about? I figured that out as a teenager. But for some reason, my learned professors were absolutely enamoured by him, as they were with Wittgenstein. But I find Popper deep. There is often something new to unlock in his work, whereas Kuhn isn't like that. You read it once, you get it. But we'll see. You can judge for yourself. Perhaps get a hold of the structure of scientific revolutions and judge for yourself. But enough of my diatribe. We're up to chapter 13, the penultimate chapter, as I say, of the Fabric of Reality, the Four Strands. And David writes, quote, "A widely held stereotype of the scientific process is that of the idealistic young innovator, pitted against the old fogies of the scientific establishment. The fogies, hide-bound by the comfortable orthodoxy of which they have made themselves both defenders and prisoners, are enraged by any challenge to it. They behave irrationally. They refuse to listen to criticism, engage in argument, or accept evidence, and they try to suppress the innovator's ideas. This stereotype has been elevated into a philosophy by Thomas Kuhn, author of the influential book, The Structure of Scientific Revolutions. According to Kuhn, the scientific establishment is defined by its members' belief in the set of prevailing theories, which together form a worldview or paradigm. A paradigm is the psychological and theoretical apparatus through which its holders observe and explain everything in their experience. Within any reasonably self-contained area of knowledge, such as physics, one may also speak of the paradigm within that field. Should any observation seem to violate the relevant paradigm, its holders are simply blind to the violation. When confronted with evidence of it, they are obliged to regard it as an anomaly, an experimental error, a fraud, anything at all that will allow them to hold the paradigm inviolate. Thus, Kuhn believes that the scientific values of openness to criticism and tentativeness in accepting theories, and the scientific methods of experimental testing and the abandonment of prevailing theories when they are refuted, are largely myths that it would not be humanely possible to enact when dealing with any significant scientific issue." End quote. So this is just a side issue, but David does mention there fraud, for example. Fraud or Maybe a more gentle modern version of fraud is sometimes called grift today on social media. Grift, the idea that you want to get paid for your weird and wacky idea, let's say, and you'll say whatever it takes in order to beef up the potential of your wild theory so that you get on social media and you get lots of followers and all this kind of stuff. That's what a grift is. Even if your idea is a bad one, you're willing to say that it's going to solve all the mysteries of the universe. So you get invited onto the prominent podcasts and onto the newscasts, and maybe you end up in the mainstream media as well, talking about your exciting idea about, I don't know, the ultimate nature of reality, the theory of everything. These things happen. Plagiarism happens. There are some scientists out there and researchers who are very good at marketing their work. They're always telling you what they are going to do without actually doing it, or very rarely doing it. And if one has the temerity to ask for, let's say, evidence of output, let's see the paper, let's see the results, let's read the book, one is told they're ignorant or incapable of understanding the depth of the theory of this unappreciated genius who's got a theory of everything. Now, that is a real thing out there. I've encountered it myself, the phenomena of the unappreciated genius, the person who works in science and has some idea. Perhaps they've rediscovered something long lost, forgotten, and perhaps even refuted, like, Lamarckism. But they don't want to admit that what they've rediscovered is Lamarckism when you point that out to them. So they won't engage with your criticisms except to say, you've not understood their point. Now, this can slow progress. It redirects people from doing productive work to criticising this crank, for want of another word. And some people are not necessarily cranks, but they might be crank adjacent. They've got a wacky idea and they're refusing to engage with criticism, engage in a critical, fruitful discussion. They're just going to ignore it and plod on, plough forward anyway. One of the worrying trends sometimes, especially in modern social media contexts where things can go viral, and the attention of, let's say, wealthy investors can be gathered by simply generating a lot of publicity, means that you can have a transfer of wealth from the people who are productive and who need it to the people who are less productive and don't really need it because they don't have good ideas. That's a form of, I suggest, dishonesty in the scientific community. But of course, it's not unique to science and doesn't actually change the fact that science still generates objective knowledge. There are, I've also noticed, and I've encountered some of them, young, up-and-coming people who have they're meek and mild. Perhaps they have lower self-esteem and they don't ask for anything much, but could do with support. And on the other hand, there are those who've got large egos or have their education and success and that kind of thing all bought for them and all gifted to them. They've never had to try and prove themselves anywhere. But they demand, and they've got the personality that pushes them in front of the people who can support them, so they'll be listened to and they'll be funded further, even for certain wacky ideas. And there's everything in between on that spectrum. But that happens, as I have said already, in business and in sport and the arts and politics and everywhere. And the thing is, despite all of that, science works. But science can be slowed down by such things, and that can irritate me. I do something in my own little small corner, as it is, to raise the profile of younger researchers and critique those who I think might be swindling people. But ultimately, I focus on the ideas and on the merit of those ideas rather than particular individuals. I don't think that analysing the sociology of how scientists sometimes behave has much at all to do with the philosophy of science at all. It's a sociological phenomenon. Sociology is not philosophy, despite what Kuhn and his followers seem to think. It's just a side issue as far as I'm concerned. It's not the main game. The main game is far more interesting because it's about ideas, it's about objective knowledge, how that knowledge is created and tested against the real world without reference to who or what group or community it's coming from. Some people are more interested in people. Some people are more interested in ideas. Let's keep going. David writes, quote, Kuhn accepts that for insignificant scientific issues, something like a scientific process, as I outlined in chapter 3, does happen. For he believes that science proceeds in alternating eras. There is normal science and there is revolutionary science. During an era of normal science, nearly all scientists believe in the prevailing fundamental theories and try hard to fit all their observations and subsidiary theories into that paradigm. Their research consists of tying up loose ends, of improving the practical applications of theories, of classifying, reformulating, and confirming. Where applicable, they may well use the methods that are scientific in the Popperian sense, but they never discover anything fundamental because they never question anything fundamental. Then along come a few young troublemakers who deny some fundamental tenet of the existing paradigm. This is not really scientific criticism, for the troublemakers are not amenable to reason either. It is just that they view the world through a new and different paradigm. How did they come by this paradigm? The pressure of accumulated evidence and the inelegance of explaining it away under the old paradigm finally got through to them. Fair enough, though it is hard to see how one could succumb to pressure in the form of evidence to which one is, by hypothesis, blind. Anyway, an era of revolutionary science begins. The majority, who are still trying to do normal science in the old paradigm, fight back by fair means and foul, interfering with publication, excluding the heretics from academic posts, and so on. The heretics manage to find ways of publishing, they ridicule the old fogies, and they try to infiltrate influential institutions. The explanatory power of the new paradigm, in its own terms, for in terms of the old paradigm, its explanations seem extravagant and unconvincing, attracts recruits from the ranks of uncommitted young scientists. There may also be defectors in both directions. Some of the old fogies die, eventually one side or the other wins. If the heretics win, they become the new scientific establishment, and they defend their new paradigm just as blindly as the old establishment defended theirs. If they lose, they become a footnote in scientific history. In either case, normal science then resumes, end quote. If any of this is true, explain Einstein. I mean, if Einstein was trained as he was in classical mechanics, Newtonian mechanics I should say, then clearly he is blind to evidence which would refute that. So too with all of the pioneers of quantum theory, who could not possibly have been able to think, because they're trapped in a particular paradigm, about how the paradigm would have been false. But they did. So it doesn't make any sense. It's incoherent on the face of it. Yes, you might want to talk about Newtonian physics as being a paradigm, as Einstein's relativity as being a paradigm, a quantum theory as being a paradigm. You can talk about these things as being paradigms, but you're not blind to the other paradigm just because you're working in one. Far from it. The people who created the subsequent paradigms that refuted the earlier paradigm of Newtonian physics understood Newtonian physics. They could think in terms of both. So that's one thing. Now, Kuhn's book, The Structure of Scientific Revolutions. Now, are there revolutions? Okay, are there actually revolutions? On the one hand, you might want to say yes, and on the other hand, you might want to say no. Let's consider why. Through a basic example we've used many times before, the move from geocentrism to heliocentrism. Is that a revolution? A huge scientific revolution? Well, it's even got a name, the Copernican Revolution. But really, all you're changing, more or less, is the position of the body at the centre of the universe, the solar system. Everything else stayed the same. All the other planets were orbiting the thing at the centre. So the orbit stayed the same and all the planets stayed the same. You just shifted the sun and the earth. Is that really a revolution? Well, maybe it caused people to think morally somewhat differently, but also remember, as we've been talking about in the myth of the framework, go to my other series about that, Copernicus wasn't the first. I mean, it goes all the way back to Aristarchus, 2,000 years before, approximately, Copernicus, as to this idea of the heliocentric theory. Aristarchus had it back then. The ancient Greeks were talking about the possibility of a heliocentric universe. So the Copernican revolution wasn't really that revolutionary. What is more revolutionary, if you're going to make the case, would perhaps be the move from something like Newtonian physics to Einstein's relativity. That's a change. That's a big change. But still, even then, in both frameworks, time exists, space exists, motion exists, okay? We're just explaining things somewhat differently. And in all those cases, when Einstein did this, he was just making incremental improvements, solving problems in order to get from where he was in classical Newtonian mechanics, I should say, and even electrodynamics, to where he got with relativity theory. He was solving problems incrementally, in other words, one at a time, and his theory eventually solved a whole bunch of them. And, you can go back and you can say, yeah, that's revolutionary, but that doesn't change the fact that he made incremental progress as well. He just made very rapid incremental progress. So it's not one or the other. It's not incremental progress versus revolution. If you're going to define the revolution as anything, it will be rapid incremental progress. But you can't get outside of this incremental progress thing, which means solving a problem one at a time. We could say much the same with Darwinism. After all, before Darwin, evolution was already known about, or at least theorised about before Darwin. It's just that its mechanism wasn't properly known. We had Lamarckism first. So we can interpret every so-called revolution in terms of rapid incremental change. As I say, this has to be the way. People solve problems, and in those cases we have individuals creating solutions to problems they found, often between theory and observation. They found a problem there, a clash of ideas. A problem is a clash of ideas. What you think about what you've observed, and what you think about what you know about the explanation of reality. But with all of these things that are usually titled revolution, it's not like everything was thrown away. Even with Popper's own epistemology, which seems revolutionary, a revolutionary split from something like Plato's, really it is just part of a tradition, as Popper himself says, stretching back to Xenophanes and before. Again, see my Myth of the Framework series for more on that. But we have to admit, there are periods of rapid change, rapid incremental progress. This is, I suppose, Kuhn's revolutionary phase. And then there are periods of normal science or slower incremental change. Perhaps that is happening in physics now, depending upon your perspective. Again, or is it? The problems seem to be accumulating in fundamental physics, or at least fundamental physics and cosmology in various places. Dark matter and dark energy seem to be pointing towards something. What are gravitational waves telling us at the moment? This so-called crisis in physics is simultaneously said to be the beginning of a new revolution or an indication of stagnation, depending upon who you ask. I mean, there are chemists out there now claiming that they've got the ultimate final theory of what time is. There are neuroscientists and cognitive scientists claiming that their theories of consciousness will somehow reveal a unification of relativity and quantum theory. So we live in wild times and wild ideas which are just being floating around and getting quite a bit of attention. There is an institutional problem with the funding of physics at the moment and science funding in general, but there's also progress and people are doing good work. That hasn't changed. Let's keep on going. This is a paragraph that I really like. David gets to the heart of why Kuhn is so attractive to people, especially in the humanities. David writes, quote, "This Kuhnian view of the scientific process seems natural to many people. It appears to explain the repeated jarring changes that science has been forcing upon modern thought in terms of everyday human attributes and impulses with which we are all familiar, entrenched prejudices and preconceptions, blindness to any evidence that one is mistaken, the suppression of dissent by vested interests, the desire for a quiet life, and so on. And in opposition, there is the rebelliousness of youth, the quest for novelty, the joy of violating taboos, and the struggle for power. Another attraction of Kuhn's ideas is that he cuts scientists down to size. No longer can they claim to be noble speakers after truth who use the rational methods of conjecture, criticism, and experimental testing to solve problems and create ever better explanations of the world. Kuhn reveals that they are just rival teams playing endless games for the control of territory," end quote. Isn't that marvellous? Kuhn's ideas are attractive to people who aren't scientists because it cuts scientists down to size. It basically says, you scientists doing just what everyone else is doing, you're just engaged in a power struggle, you're not really finding truth or objective knowledge, you're just engaged in fashions and you're just as human as the rest of us. Well, it's true, they're just as human as the rest of us. But the misdirected criticism is to think that because scientists are human, that the process of science is somehow flawed because of that. It isn't, any more than the process of mathematical proof is flawed because of the fallibility of human beings. You're not going to get absolute truth out of it, but it doesn't matter how mathematicians are behaving. It matters whether or not the proof is valid. We can check that. Everyone can check it to their own satisfaction. And the same is true in science. Anyone can check the evidence or the paper and convince themselves that the paper is good or bad based upon their own critical faculties. That's the measure, not whether or not it's a fashionable theory to believe in or anything else. David continues, quote, "The idea of a paradigm itself is unexceptionable. We do observe and understand the world through a collection of theories, and that constitutes a paradigm. But Kuhn is mistaken in thinking that holding a paradigm blinds one to the merits of another paradigm, or prevents one from switching paradigms, or indeed prevents one from comprehending two paradigms at the same time. For a discussion of the broader implications of this error, see Popper's The Myth of the Framework. Admittedly, there is always a danger that we may underestimate or entirely miss the explanatory power of a new fundamental theory by evaluating it from within the conceptual framework of the old theory. But it is only a danger, and given enough care and intellectual integrity, we may avoid it. It is also true that people, scientists included, and especially those in positions of power, do tend to become attached to the prevailing way of doing things and can be suspicious of new ideas when they are quite comfortable with the old ones. No one could claim that all scientists are uniformly and scrupulously rational in their judgment of ideas. Unjustified loyalty to paradigms is indeed a frequent cause of controversy in science, as it is elsewhere, end quote. Okay, so David has just said there, unjustified loyalty to paradigms is indeed a frequent cause of controversy in science, as it is elsewhere. So I might add, not merely that scientists in positions of power become attached to the prevailing way of doing things, as David says, but they can also advance their own agendas, let's say as hinted at here, by only promoting their own ideas. It seems as if some, no matter how high they climb in the social hierarchy or in the scientific hierarchy or whatever it happens to be, especially today, there's this interesting phenomenon of scientists as social media star to a large extent, or the person who appears on lots of podcasts and various things, but who feels as if they're unappreciated. Their genius, as I said, is unappreciated for whatever reason. Those people, not only are they excellent at self-promotion, it seems sometimes that they also want to keep down the competition in a lot of ways, which is an interesting phenomenon. These people who have the ultimate theory of the universe, or the theory of ultimate reality, or their own new interpretation of quantum theory as being the one true and unappreciated one, that these people think that they're such original thinkers. They don't understand why they're not appreciated by their colleagues more. They might get to go on all the famous podcasts and so on and so forth. And there, on those podcasts, they will pour scorn upon the entire scientific community for not appreciating their genius, or not being ready for their genius, let's say. They all talk of themselves as being something like, or without so many words, as being the next Galileo, being somehow kept down by the establishment for whatever reason. Now, such people, I'm not part of the scientific community, but I'm adjacent to it, okay? I get to speak to a lot of these people. And you do see it, that sometimes the people who are very good at self-promotion, you get the strong impression at times that with some established academics, they will even thwart young upstarts. Not because the young upstart necessarily has some brilliant new idea, but because the young upstart won't sufficiently praise the work of or flatter the older professor or the researcher. Again, that's not unique to science, and it has little effect, ultimately, upon the creation of objective knowledge in the sciences. It's a speed hump. It's a nuisance. It's an aspect of human culture, and driven in large part by anti-rational memes and bad ways of thinking. People striving to become, let's say, celebrities. And the celebrity scientist is a real thing. There are some excellent, absolutely excellent celebrity scientists. I think of people like Brian Cox. I think he's a really good science promoter. And simultaneously, he's a reasonable scientist as well. He works at the Large Hadron Collider. He teaches courses. He seems to be a good scientist and an excellent communicator. Now, there are others, names won't be mentioned, who are very good at self-promotion, as I say, but their scientific work just doesn't add up. It doesn't stack up. They make huge claims. This is something Brian Cox doesn't do about his own work. He's very, very modest. There are people who are very, very modest about their own work. You spot them. Everyone can see. And everyone can also see the people who, well, they may not be charlatans, but they're charlatan adjacent, or at least, no, I should take that back. Many people cannot spot the charlatan. Many people will promote the charlatan, or the grifter, or the person who is making big claims. And in fact, they want to have that person on the podcast or the program, because that person will say, I'm solving consciousness. I'm solving the nature of space and time. I'm going to reveal to you the way in which to unify relativity and quantum theory. I've seen what no one else can see, and no one understands the brilliance of my new paper. Here it is. I'm going to give you the new paper, and you won't understand it because you're just a podcaster. But trust me, it contains the secrets to the universe. Something like that. Now, you do hear that kind of thing spread out over a 2 or 3 hour podcast, but it's what kind of they're hinting at or circling. And I've listened to these people who claim to have solved consciousness, the nature of space and time, revealed the final theory of everything, unified quantum theory and relativity, and I know that it's false because I can read some of the papers some of the time and I can understand what they're saying. I can speak their language, so to speak, in terms of science. And if I don't, then I'll ask someone who can, if there's a technical detail, and reveal and understand there's usually a poverty of detail there. They're making grandiose claims because there are some wonderful philanthropists out there. There are some wonderful people who will do great work in sponsoring scientists, established and up and coming. And unfortunately, if you make a big claim and the philanthropist, the investor, doesn't understand the science, but understands your marketing, you might very well get a generous grant. I've seen it happen. So this is why it irritates me, because I'm interested in promoting and trying to get funding for and to assist people who really deserve it, who are doing legitimate work, but who aren't making big claims. So there is a tension here between people who speak in very fallibilist, conjectural, Popperian, modest terms about what they're doing, and those who have no compunction about saying they are just around the corner from solving life, the universe, and everything. They're just around the corner from developing AGI. They're just around the corner from telling you what consciousness is. In fact, they might have already figured it out, and they're about to write a book on it. They just need another grant of $200,000, and the book will be published, and will solve humanity's problems. This is a timeless phenomenon of human nature. And the first time I was aware of this kind of thing was the cold fusion debacle, as I say, where the scientists claim to have done something that they never actually achieved. Now, it might have been an honest mistake. It's hard to tell in retrospect, but it seems like those people doubled down. And there are many such grifters now. You have a word for these people. Snake oil salesmen, right? So they're not all like this. Maybe I've misunderstood some of them, but they're out there on social media and they're out there on X. And anyway, I don't know how we fix that, or whether we necessarily need to. People just need to be a little bit more critical. Perhaps this kind of, these anti-rational memes that people have about being unwilling to critique their own ideas really effectively at times, maybe that's just a consequence of how creativity works. Well, we don't understand creativity as well. That's another grift that people have. They claim to have the theory of creativity. As David Deutsch says, if you think you've got the theory of creativity and consciousness, program it, show us. No one does. But maybe these bad ideas that people have, this tendency towards grift and self-promotion, maybe it's a consequence of being creative. And if we were to try to eviscerate these impulses from people and scientists to try and get them to be more critical, self-critical, more rational, let's say, it may have the effect of dampening creativity in the individual and overall. I don't know. It could in fact be the opposite. I can imagine either being true. Or neither. David continues, quote, "But considered as a description or analysis of the scientific process, Kuhn's theory suffers from a fatal flaw. It explains the succession from one paradigm to another in sociological or psychological terms, rather than as having primarily to do with the objective merit of the rival explanations. Yet, unless one understands science as a quest for explanations, the fact that it does find successive explanations, each objectively better than the last, is inexplicable. Hence, Kuhn is forced flatly to deny that there has been objective improvement in successive scientific explanations, or that such improvement is possible, even in principle." A quote from Kuhn now. And Kuhn writes, quote, "There is a step which many philosophers of science wish to take and which I refuse. They wish, that is, to compare theories as representations of nature, as statements about what is really out there. Granted that neither theory of a historical pair is true, they nonetheless seek a sense in which the latter is a better approximation to truth. I believe that nothing of the sort can be found." End quote. That's from Lakatosh and Musgrave, editors, Criticism and the Growth of Knowledge, page 265. Well, now, I don't know what to make of that, and we would it would be interesting to hear from Kuhn how he explains the precision, let's say, of a GPS system programmed with Newtonian physics versus the same system programmed with general relativity. The latter can have a precision up to centimetres or millimetres indeed. Okay, it can find your position on the Earth down to the nearest few millimetres. But Newtonian physics will get it wrong increasingly day after day after day by a matter of metres, then hundreds of metres and so on. So what explains this convergence on what is really going on? So Kuhn is saying that of science being able to produce a better approximation to the truth, he thinks nothing of the sort can be found. Nothing of the sort. Now, it's true that in the Popperian scheme you won't get final truth, but the idea that theories in science are about what is really out there is a true one, or else it's all just narrative. And some people are attracted to this idea that, we're all just telling stories, and Popper, in fact, talks about science beginning in myth. But it's not just myth, because it's myth that makes contact with reality. Ultimately, we expect to turn over one myth, replace it by another, or one misconception replaced by another. But that doesn't mean we're still not converging on something that is real, genuinely out there, and we're uncovering some of that truth sometimes. The fact is that electrons and planets are really out there. Whereas if you're in the humanities and you listen to Kuhn, you go, aha, there we go. Maybe it's impossible to know whether they're really out there. Now, if you endorse the justified true belief notion of knowledge, then yes, okay, it's impossible to know. But it's impossible to know anything because you never justify anything as true. But if by the word know you mean conjecturally, then we can know what is out there to some approximation, just never finally. But planets and electrons and elephants are out there, and we can say that. We can say that we know electrons and planets and elephants are out there. And we can come to know about those things ever better over time by correcting our errors in our existing explanations of them. And when we do that, we've learned more. Indeed, taking seriously that, for example, atoms existed, and they do, led to electrons being discovered. But it didn't refute that atoms existed, it only refuted that they were fundamental. They couldn't be broken down into anything more simple. Now we think, our present theory states, that electrons are fundamental, or at least we have no better theory that they're made of anything. Although people are looking, taking either side of that debate as either reasonable or irrational depending upon your perspective. You might say it must be one or the other. It must be that electrons are either fundamental or they're made up of smaller constituent parts. Or you might say taking either stance right now would be irrational, as there's no reason to presume either yet. It's an outworking of the tension, by the way, between the continuous and the discrete, that ongoing debate. What is the ultimate nature of reality? Is it continuous? Can you just keep on dividing up, finding ever smaller things? Or will you get to a fundamental building block? Oh, the beginning of infinity, the entire philosophy would say, it's continuous. We're just going to keep finding smaller and smaller things, things inside of other things inside of other things. Or even if we found a stopping position of a smallest possible particle, maybe there are other ways in which we can break down the constituents of the universe, just perhaps not in particle terms, something else. David goes on to say, quote, "So the growth of objective scientific knowledge cannot be explained in the Kuhnian picture. It is no good trying to pretend that successive explanations are better only in terms of their own paradigm. There are objective differences. We can fly, whereas for most of human history, people could only dream of this. The ancients would not have been blind to the efficacy of our flying machines just because, within their paradigm, they could not conceive how they work. The reason why we can fly is that we understand what is really out there well enough to build flying machines. The reason why the ancients could not is that their understanding was objectively inferior to ours." End quote. Perfect. And as I will come to towards the end here, all you need to do is go into a hospital and have a look around. Things are getting better. Any piece of technology that you have around you right now is an indication that we've understood something truly about the nature of reality. And because of our understanding, we've come to control reality. This is objectively true. It takes a lot of work to deny the fact that we're actually accurately, to some extent, uncovering the nature of reality. I'm going to skip a little and go to a parable of a sort that David talks about using his own experience as a researcher, as a scientist. And he invites the reader to consider what it's like to be in a professional scientific seminar, because that refutes this Kuhnian picture of the way in which science is done. As he says, quote, "You only need to attend a research seminar in any fundamental field in the hard sciences to see how strongly people's behaviour as researchers differs from human behaviour in general. Here we see a learned professor acknowledged as the leading expert in the entire field delivering a seminar. The seminar room is filled with people from every rank in the hierarchy of academic research, from graduate students who were introduced to the field only weeks ago to other professors whose prestige rivals that of the speaker. The academic hierarchy is an intricate power struggle in which people's careers, influence and reputation are continuously at stake, as much as in any cabinet room or boardroom, or more so. Yet, so long as the seminar is in progress, it may be quite hard for an observer to distinguish the participants' ranks. The most junior graduate student asks a question. Does your third equation really follow from the second one? Surely that term you omitted is not negligible. The professor is sure that the term is negligible and that the student is making an error of judgment that someone more experienced would not have made. So what happens next? In an analogous situation, a powerful chief executive whose business judgment was being contradicted by a brash new recruit might say, "Look, I've made more of these judgments than you've had hot dinners. If I tell you it works, then it works." A senior politician might say in response to criticism from an obscure but ambitious party worker, "Whose side are you on anyway?" Even our professor, away from the research context, while delivering an undergraduate lecture, say, might well reply dismissively, "You better learn to walk before you can run. Read the textbook. And meanwhile, don't waste your time and ours." But in the research seminar, any such response to criticism would cause a wave of embarrassment to pass through the seminar room. People would avert their eyes and pretend to be diligently studying their notes. There would be smirks and sidelong glances. Everyone would be shocked by the sheer impropriety of such an attitude. In this situation, appeals to authority, at least overt ones, are simply not acceptable, even when the most senior person in the entire field is addressing the most junior. End quote. That reminds me of Sam Harris somewhere making a similar point. I don't know if he said exactly appeal to authority, but to paraphrase him, he said something like, in a scientific seminar, you're as likely to see an appeal to authority as you are to see nudity, which is about right, okay? Because people are there, ostensibly, to do science, to do the rigorous thing of checking and correcting, checking the work of each other. And so they're going to have discussions, fruitful discussions. Let's keep going. Our professor has just been asked a question about whether the third equation follows from the second. David goes on, quote, "So the professor takes the student's point seriously and responds with a concise but adequate argument in defence of the disputed equation. The professor tries hard to show no sign of being irritated by criticism from so lowly a source. Most of the questions from the floor will have the form of criticisms which, if valid, would diminish or destroy the value of the professor's life work. But bringing vigorous and diverse criticism to bear on accepted truths is one of the very purposes of the seminar. Everyone takes it for granted that the truth is not obvious, and that the obvious need not be true, that ideas are to be accepted or rejected according to their content and not their origin, that the greatest minds can easily make mistakes, and that the most trivial seeming objection may be the key to a great new discovery." End quote. So, as I've hinted at, social media reveals some of this brilliantly. The appeals to authority one can tend to see on social media, on X or Facebook or wherever, when it comes to science or anything else, is astounding. It can be astounding anyway. Some want you to defer to their expertise, not because of the content of their argument, but because of the length of their credentials or perhaps the refereed papers they have and so on and so forth. How they behave in the seminar is so far away from how they behave on social media, it's as if some scientists and academics and intellectuals more broadly have entirely separate personalities. Perhaps they do. I think we've all known people who can seem to be reasonable in one mode and then overly attach to their ideas as if their ideas are their identity in another. As I've said so many times before, people merely have ideas. They are not identical to their ideas. Now, as a description, that is true. People generate ideas, it's what we do, it's what we are. But as a normative claim, which is to say a prescription about how to behave, almost no one can pull it off all of the time. Namely, detach yourself from your ideas. Do not feel personally attacked if someone attacks your personal theory as nonsense. Now, I have a few theories I regard as unique to me, or at least I think I do. For example, I once conjectured, here in this YouTube video, that consciousness and creativity are the same thing. I did this one a few years ago, and even David Deutsch said that I might be right about this, and he retweeted it, so to speak. It was an interesting video. I quite enjoyed making it and putting it out there. I conjectured that consciousness and creativity were the same thing. But when I did put it out, I simultaneously said that I didn't believe it. I also don't believe that it's false. I just don't know. I was exploring the idea. And now, in rereading this chapter, right now, presently, The Fabric of Reality, chapter 13, rereading it for Talkcast for I don't know how many times I've done it before, I didn't realise that this thought about consciousness and creativity being one and the same kind of thing, or at least very similar things, I thought that I'd created that myself, but I didn't, because in a throwaway line we'll come to, not until the next part of this chapter, David says exactly the same thing. So it's one of those things that I seem to have absorbed by osmosis unconsciously somehow, and years later re-remembered it and developed it and thought it came from me, but it didn't. It seems that David got there earlier and elsewhere, as we say. In any case, I've not been attached to this idea about consciousness and creativity being two sides of the same coin. I can imagine that it's true or false. I'm curious about both consciousness and creativity. Now, whether they're one thing or not, I don't know. If anyone makes progress on either consciousness or creativity, then I'm interested. I'm curious about it. I want to know what they are, how they work. So I read all the stuff from the sober kind of discussion about what these things are through to the crazy. Lots of people get attention when they claim to have a new theory of consciousness or creativity. There are a heck of a lot of them out there right now. I find none of them persuasive, including my own. As David says, if they understood it, they would have programmed it. Okay, we're just about at the end of our reading for today. Just a little more, and a little more commentary, and we'll bring it to a close before I move on to part 2. David writes, quote, "So the participants in the seminar, while they are engaged in science, do behave in large measure with scientific rationality. But now the seminar ends. Let us follow the group into the dining hall. Immediately, normal human social behaviour reasserts itself. The professor is treated with deference and sits at a table with those of equal rank. A chosen few from the lower ranks are given the privilege of being allowed to sit there too. The conversation turns to the weather, gossip, or especially academic politics. So long as those subjects are being discussed, all the dogmatism and prejudice, the pride and loyalty, the threats and flattery of typical human interactions in similar circumstances will reappear. But if the conversation happens to revert to the subject of the seminar, the scientists instantly become scientists again. Explanations are sought, evidence and argument rule, and rank becomes irrelevant to the course of the argument. That is, at any rate, my experience in the fields in which I have worked. Even though the history of quantum theory provides many examples of scientists clinging irrationally to what could be called paradigms, it would be hard to find a more spectacular counterexample to Kuhn's theory of paradigm succession. The discovery of quantum theory was undoubtedly a conceptual revolution, perhaps the greatest since Galileo, and there were indeed some old fogies who never accepted it. But the major figures in physics, including almost all those who could be considered part of the physics establishment, were immediately ready to drop the classical paradigm. It rapidly became common ground that the new theory required a radical departure from the classical conception of the fabric of reality. The only debate was about what the new conception must be. After a while, a new orthodoxy was established by the physicist Niels Bohr and his Copenhagen school. This new orthodoxy was never accepted widely enough as a description of reality for it to be called a paradigm, though overtly it was endorsed by most physicists. Einstein was a notable exception. Remarkably, it was not centered on the proposition that the new quantum theory was true. On the contrary, it depended crucially on quantum theory, at least in its current form, being false, end quote. And so we are leading into our discussion of the first of the four strands, quantum theory, and what it looks like through the lens of Kuhn and Popper, and whether or not these old fogies were really incapable of seeing a new way of envisaging what reality was all about. David's, of course, going to talk about what the Everettian picture adds to this, and what kind of social forces there were if any, which come to bear on the extent to which ever it was taken on by the physics community. Since the book was written in 1997, more and more physicists now are comfortable with endorsing the Everettian picture, the multiverse in other words. Some others still want to rediscover the wheel and will refuse to admit reality is multivariate, for example. They want to have their own paper on their own interpretation of quantum theory dutifully highlighted in yellow pen, as Dawkins once said about intellectual imposters. The rational thing to do is, of course, to just put your work out there, wait for feedback and keep on working. I know with Talkcast, for example, I put episodes out and I think, what a shoddy job. I really should clean this up. I should re-record the whole thing because, well, it didn't take me very long anyway. And yet, I'll put it out there anyway, and that episode will get thousands of views. And then, at other times, I'll spend over a week carefully crafting some episode by reading, making notes, reading again, recording, editing, error checking, and finally publishing, only for almost no one to notice. It seems from my perspective there's no rhyme or reason why some things are popular and get traction and others are not. But I'm not a scientist. I've merely dabbled in physics, and what I accomplished there in astrophysics was embarrassing when set against any real physicist and what a real physicist does. So I've never had this experience of being attached to my results or my theories, for example. But I can imagine being a physicist or other scientist who spends some years carefully crafting an idea before publishing it, only to have it languish, or at worse, immediately refuted by someone who says, well, it's not physics, it's untestable, it's just mathematics, elegant though it is. Or worse, they might very well give me the feedback that I've just rediscovered something found by physicist John Smith in 1964, who called that idea something a little bit different, but you clearly didn't read the paper. I've seen both of these actually happen. Reasonably famous public intellectuals crying from the rooftops effectively about their theory of everything, or almost everything, which turn out to be either just mathematical curiosities that lead to no experimental test, or just a mathematical curiosity that has already been published elsewhere and earlier, and which likewise leads to nothing much new, and again, no possible experimental test. And when this is pointed out to them, they get astonishingly prickly, and they retreat emotionally behind a wall of, my critics do not understand anything about physics, for example. And I've seen this in one case by someone who wasn't even a physicist, claiming that they, a non-physicist, understood physics in a way the physicist didn't, and that no physicist could. Now, in some cases, they might actually be right, but I don't think so in this case, for example. I find all of it fascinating. Now, Kuhn elevates all of that kind of stuff to a sort of theory of all of science. But it's just not. It's, at best, a theory of human behaviour, and science stands apart from all that. Science is what you get despite what humans sometimes tend to do wrong. After all, it may very well be, as I've said, that the process of science is slowed down a little bit at times by that behaviour. Resources may be misdirected because of it at times, but it's not everything. It's a side issue. How science proceeds is via the process of making bold conjectures, guesses about the nature of reality in an attempt to solve some problem, and then by testing them in the real world using experiment. And that enables us to refute some ideas some of the time, and in this way make objective progress away from explanations that are known to be false towards theories not yet known to be false, and which allow us to glimpse more of what is really out there, what exists and how it behaves, and even in some cases to use those explanations and models of reality not only to make predictions, but to create technologies and make human life better. And it's very hard to argue against that life is better and getting better, that technology has improved and is improving, health and wealth increases. We can peer inside a hospital, as I say, and say, wow, look at that. Look at all of that equipment, all of that physics, chemistry and biology literally improving the lives of people, and possible only because scientists have improved their ideas about actual reality. We can see that, and we refute the idea that only the theories that survive some sort of social peer pressure fashion test actually win. No, that's just not true. It is ideas, explanations, scientific theories that objectively get closer to reality, a truer description of reality that succeed. It's not easy. Objective knowledge is hard won, but it's a real thing. And anyone who goes to a hospital, or who has a smartphone, or plugs in their electric car, or flies in a modern jet will know science is not like fashion at all. Skirt lengths may be arbitrary, but our knowledge of the laws of physics is not. Kuhn was wrong. Popper is right, and all one needs to see this is clear eyes and a rational appreciation of modern technology and where it comes from at root. In any case, this is a very deep topic. Popper and Kuhn did in fact encounter each other once and discuss their ideas. And as with Popper encountering Wittgenstein and debating him, there was a book written about the encounter. So I did that with this episode, Mr. Popper's Problems. It was about the book of their encounter, Wittgenstein's Poker, that's the book. And I may do the same with Kuhn versus Popper. That's actually a much longer tale because there's more characters and so on, but it's symmetric in a way because the establishment academics all agree Popper lost in both cases. Culturally in academia, no doubt, I suppose. But more broadly, we know Popper was right while Kuhn and Wittgenstein were fundamentally wrong. Okay, that's enough for now. Until next time. Bye-bye.